Our final talk for the morning is from Andrew Holland. Andrew is the CEO of the Fusion Industry Association. So Andrew, as hard as it is to follow that, I turn the floor over to you.
Great, very hard to follow that. A great talk, and I've been able to listen in some throughout the morning, afternoon here, coming to you from Washington, D.C. So let me see. I'm going to share my screen here. Well, first of all, great to be with you. Really excited to be a part of this. My name is Andrew Holland, Chief Executive Officer of the Fusion Industry Association. The FIA is a fairly new nonprofit business association, and I'll get into our membership here and our goals and targets and everything like that. I know you all here are here to talk about the roadmap to 2030, but since we're talking about Fusion, I want to say the roadmap to 2030 and beyond, because I think as optimistic as I am about fusion energy, it is a big stretch to go to expect there to be fusion making a meaningful impact on net zero targets or anything by 2030. But I would put it to you that it is in fact imperative for the net zero targets by 2050 to be able to increase energy access both here and around the world, increase energy usage, and decarbonize at the same time. I put it to you that fusion is the one thing that can actually meet that challenge. So let's go into this a little bit more. Here's our FIA membership. There is currently 28 member companies of the Fusion Industry Association. These range from companies as small as a couple of guys in a garage, all the way up to multi-billion-dollar venture capital-backed companies. The unified thing that brings them all together is they're all working to achieve commercial fusion energy, and they all have raised private capital to do so. It's an exciting time in this. The members are a broad range of technologies, broad range of approaches, and we'll get into that even more. But I think we have to first start to talk about, I know you've heard a range of technologies and approaches and ideas today as you think about the 2030 targets. Of course, you're going to get into renewables. Of course, you're going to get into carbon capture, everything like that. So why do we talk about fusion? Why do we need fusion innovation? Don't we have the tools for decarbonizing the energy system now? Why do we need more? Well, the answer I'd put to you is that fusion solves the hard problems. It's a climate solution. Yes, of course. It's also an energy security solution. It will end the geopolitics of energy. We no longer will have to think about where an energy resource comes from. No country will be able to control an energy resource. It will instead become a manufactured product, something you build in a factory and then supply to the world. And that really fundamentally changes how we think of global geopolitics and everything. Enables grid reliability. It's going to finish the job that renewables have started, and it's the industry of the 21st century. So let me just kind of underline this. Fusion will light the darkness, provide the jobs and industrial base of the 21st century, and make for a more peaceful world. And let's get into this a little bit more. How will fusion change the energy outlook for 2050 net zero? And you know, I know as we're talking about the 2030 50% reduction goals, and I pulled this chart from this is from the IEA, but you could pull similar charts from multiple different projection agencies, and they all kind of tell the same story. We saw Arati's presentation before too, showing that the projections are that yes, there'll be increased renewables, increased wind, solar, such like that. But still, oil, coal, even coal, still onto the grid by the 2050s, natural gas. And so you need something that can scale rapidly and fit in there. And then I'd also say that the projections for energy demand, if you look at this, are really quite flat. Actually, it has it going down and then back up. I'd put it to you that what we need is an increased amount of energy. Energy, so long as it's clean, zero carbon energy, is a good. It's a global good thing. Provides wealth and provides a whole range of things that we need here and around the world. So if we were to have that curve going up and all the rest and this all going down, there's a tremendous marketplace in there. So that the largest use case will be nearly unlimited clean, firm power, but it will also fit into the other markets: industrial heat, hydrogen, desalination, marine propulsion, clean fuels. All of this can make a difference to get to the real net zero global needs that we need by 2050. So a little bit about the private fusion industry today. And this picture is from our Global Fusion Industry in 2021 report, available on our website, fusionindustry.association.org. But we've actually got a new one in the process right now that will be launched in July. We're just getting the final responses to our surveys in. So these numbers are updated based off of that. There's 35 private fusion companies around the world. 28 of them are members of the FIA. 20 of them are American companies. There's over $4.4 billion invested. And of that, way more than half of it has come in the last 12 months, 135% in the last 12 months. So it's a significantly increasing curve of investment that's relevant to the excitement that we saw in 2021 in fusion. Justified excitement. We're hitting our milestones and we're getting where we need to be to get to commercialization in the 2030s. Next slide here. And a couple other things we've done in this survey. Our target markets, the main target markets are electricity generation, but it also includes space propulsion, marine propulsion, all of these others as well. And so all of these can grow for fusion. And the technological approach taken by fusion companies. So this is important because I don't know how much you all know about the various approaches to fusion, but there is no one single technological approach to get there. You may have heard of tokamaks, you may have heard of inertial fusion energy, laser-driven inertial fusion energy. Well, the truth is that of the 28 member companies of the Fusion Industry Association, there's no direct overlap in technological approach for any of them. So that means we have various different sorts of magnetic confinement, various geometries of that. There's magneto-inertial, which kind of comes in the mid-range between laser-driven and magnetized. And then there's inertial fusion energy companies. So without any planning, there's really no FIA members pursuing the same approach. So this is kind of what happens when investors accept technological risk in the search for innovation and speed. And this private sector approach is kind of different from the unified government approaches around the world, which have all narrowed down in on the one tokamak-based approach that has been taken by the Global ITER Consortium. I think it's important that there is this broad risk. So again, let's talk about your 2030 goal. Here's our timeline. This is the industry's broad vision, and I'll acknowledge that this is bold and this is direct. This is an accelerated timeline, and it's demanded by investment schedules, but it's also demanded by the increasingly urgent needs of the climate crisis. Now, of course, companies are all going to have various different things, but this timeline is broadly indicative of all of our companies. So right now, we're at the time where we go from 60 years of research and the scientific basis for fusion energy. That's what we saw in 2021. We saw, real reports from the National Ignition Facility in California, from JET in the UK, giving us real concrete basis that we know enough about fusion that this is ready to move from the labs into the marketplace. So what's happening now is that companies are building their scientific proof of concept machine. And by the mid-2020s, they'll get to this. They'll build out their scientific proof of concept, and then at the same time, start building, designing, and siting pilot plants. These would be demonstration power plants putting energy out onto the grid. They'll need to operate for several years to show customers that this is something worth buying, that this is something that can be economical. And then that puts us into the mid-2030s at the era of commercial fusion, rapid scale up to global deployment. And I think that's what's really important here to think about, is that fusion, the key thing here is that fusion can grow at scale. And so this map here is just kind of a data of all the power plants all over the world. And I think if you look at it, you can see the density. Climate change, it means that we have to change almost all of this with clean, sustainable energy sources. So by doing that, by getting fusion into this, it's a huge marketplace. We have to, building the first plant is not enough. We then have to build thousands. But this is the largest market in history. And for example, revenue of publicly traded oil companies are bigger than many countries. There's 10 million people employed in renewables here in the United States alone. This is huge. So that's why it's such a big marketplace, why we're so excited. And let me just kind of give you a quick look at, what our vision is 2 decades out, and then we can kind of scale it back. And that gives us an idea of where we need to be over the next 8 years as we get to that 2030 goal. And then what we need to be doing right now. So in 2 decades, our vision is that commercial fusion industry will be a new manufacturing industry. This will look more like traditional manufacturing things than it will look like the traditional energy industry. Here's aerospace, car manufacturing, even the manufacturing of gas turbines here. But this is at scale, supporting multiple power plants being built per day, providing the wealth and climate and energy security that's needed, and the scientific innovation that will continue to build this along. Once you have a manufacturing industry, you learn by doing, you iterate, and it becomes more and more efficient, and you drive costs down. That's what's so exciting about this. So by 2030 is that, and the picture here is of the National Academy of Sciences report from a year and a half ago, which outlined what bringing fusion to the US grid would look like. What are the steps and scales? And this is largely our blueprint for what we need to be doing. We strongly support all of the outlines in there. Industry is going to be building multiple fusion pilot plants of different sizes, technologies, and fuel cycles in that time frame. We're going to have to be working with governments to support this commercialization push. They're going to provide the science, computing power, user facilities, basically the infrastructure that enables a fusion industry, while the private sector builds the demonstration plants that will show how it works. And then, of course, scientists and universities are going to form the backbone of the fusion workforce and train the next generation of workers in this industry. And so again, working backwards from there, in the next 5 years or so, we're going to see our Kitty Hawk moment or moments, these proof of concepts in the mid 2020s. And again, just to remind you, this is when we prove that fusion will work, not when we're selling the power. It's when the airplane takes off. It's not when you start selling tickets. But government support will lead to this. And this is what I spend most of my time doing here in Washington, is working with Congress, working with the Department of Energy. I'm so happy to see Sally Benson from the White House on here, working with the White House on how to build that bold decadal vision that she talked about, and how to implement a new milestone-based development program. I'm happy to talk about this more in Q&A and what it looks like and where we're going. But we really think that the U.S. government and governments around the world have a key role to play in accelerating this and moving the timeline ahead. And to give a little bit of detail about this, on March 17, Sally did a great job organizing the fusion industry and the whole fusion community to come together at the White House to start a conversation on what the bold decadal vision for commercial fusion energy is and would be. There's Secretary of Energy Granholm speaking in the keynote remarks, and you can see the panel here at the bottom. There I am talking about what's the industry's vision and how we're moving forward on this. It was really a great day and really a important, I think, milestone that shows the aggressive move by the U.S. government and by the private sector towards the commercial fusion future. And a kind of a reminder to all of us here, this is a global competition. The U.S. doesn't act to accelerate fusion energy. The world won't wait. And what's at stake is leadership and competitiveness in the next great new industry of the 21st century. I think it's obvious to those of us in and around fusion that the UK actually is right now the world leader in planning for fusion. They've put together a bold government operated pilot plant plan that they're calling STEP, that will be operational by 2040. They have robust outreach to private partners, and they have a draft approach to the regulation of fusion energy under the lead of their environmental and occupational safety regulators, not their nuclear regulator, and are moving forward on that. But our global strategic competitor is moving too. China is beginning to rapidly scale up their fusion work after announcements of records in plasma confinement at their tokamak in Hefei. They're building a new campus of R&D for fusion power plant components. And last summer, they approved building of a new burning plasma experiment they're calling BEST by 2027, moving towards their demo pilot plant in the 2030s. Other moves include the new Japanese Prime Minister announcing that they will determine their government's plan for commercialization of fusion this year. And the EU, the largest funder to date of ITER, is beginning a planning process to determine how to accelerate European fusion as well. So this is moving rapidly around the world. And so what do we need to do right now? Couple of key things that I'm working on with the government. We're working on trying to build this partnership with the Department of Energy. We're working to direct federal support to fusion energy. And then finally, and we're working to ensure regulatory certainty. We have to make sure that we have the certainty pretty much right now, within the next year or so, of what the fusion regulatory environment will be, so that we can make the investments to build these pilot plants that we need to do and where we need to go. we're going to get to fusion at some point, but fusion in a decade will be hard. And I like to end with this quote from FDR. The country demands bold, persistent experimentation. It's common sense to take a method and try it. If it fails, admit it frankly and try another. But above all, try something. So fusion in a decade will be hard, but it'll be worth it, and it's worth some experimentation. I'm really happy to be with you all. Thank you all for all your work in doing this, in bringing together this group. And I'd love to take the rest of my time here to answer some questions, have a conversation, hear what else is going on. So thanks.
Thank you so much, Andrew, for the overview of where we are in the fusion world. There are a few questions here, so let me start running through some of them. The first question is that you seem to be very focused on electricity generation as compared to, say, industrial heating, which is an area that we've heard throughout the last couple of days is one that that really is in need of alternate sources to get us off of fossil-based industrial heat. Is there a reason why you can't start by focusing on that space?
Yeah, so it's market response, I think. The electricity generation is just so much of a bigger global market. It's electricity generation is the way to make the trillion-dollar industry. At this point, industrial heating is yes important, and I think is important. You're right. It has an outsized importance in this decarbonization side, but electricity is, let's be clear, electricity is where the money is. So, fusion wants to be a successful commercial venture. It needs to make money.
Okay. So there's a few questions here that are both that are hitting the same questions around sort of minimum size, trade-offs in different sorts of fusion plant sizes. Maybe you can talk a little bit about that. I know that there's a lot of different, you talked about the sort of portfolio of different types of fusion approaches that people are taking, but maybe you could talk a little bit about sort of what seems most promising in the areas of small, medium, and larger size.
And I really just had time to do kind of a broad overview, but fusion has been, and kind of the big international fusion program, the ITER pathway, has been hamstrung by being too big. And so when you build power plants, when you build demonstrations, even experiments that are too big, when you scale so big, it just gets expensive to build things like, just basics like steel and concrete, not even the high technology parts. Right. Gets so expensive. So one of the key technological innovators for some of our companies is the application of high temperature superconducting wire. And so what that allows you to do is to build magnets that are much smaller and more powerful than existing magnets. And so that enables you to scale down. And as you scale down, because the power within a fusion plasma scales to the third power, and I'm not a scientist, so I always ask, go on. It scales very rapidly. So when you're able to shrink the size, you're able to increase the power rapidly. So for instance, Commonwealth Fusion Systems, one of our member companies, the MIT spinoff, their power plant is quite small, but will be at the same scale in terms of power output as ITER. I think it's a 60th of the size of ITER. So that allows you to bring down the cost significantly. Now, to kind of very specifically answer the question, there's a range. There's some companies that are looking at kind of the 500 megawatt scale. 300 is pretty common. I think replacement for combined cycle gas power plants puts you in kind of the 250 to 350 megawatt range. That's really kind of the target bogey. There's some that are looking up to something like 800 megawatts. There's really no one playing at the gigawatt scale. Okay. And then there's a bunch of smaller ones too. There's ones, Helion Energy, for instance, is doing a 50 megawatt plant. And then there's even ones doing 10 megawatts. And we actually have one member company that's doing kind of a kilowatt scale thing, almost something that you could, like a backpack size fusion. So the whole range of things.
Great. So I wonder, as a sort of general conversation, imagining that we do see the sort of technical successes that need to happen over the next decade or so to start to convince people that there's a possibility of rolling these things out. How do you keep, we were talking with Arthi in the last session about social innovation, and I brought up fusion as an example where there's sort of a lot of questions about customer acceptance and sort of regulatory hurdles that might get put up. So how do you think about keeping fusion from getting caught in some of the same traps and hurdles that have affected the advanced nuclear fission space over the last couple of decades?
Yeah, it starts by being open. It starts with having direct conversations, both with, kind of at the grass tops. So with regulators, with the NRC, with state level regulators, and we're doing that right now. I spend a lot of my time thinking about and preparing for engagements with the Nuclear Regulatory Commission. So things like that. And then it's also, the social license is about learning what it is that people are actually concerned about and being responsive to that. And that just takes, that takes work, just direct meeting, everything from polling and, and kind of direct one-on-one, or group meetings. When you're siting and building a proposed power plant, you got to just figure out where the community is and go in and talk to the community and learn what their challenges are. So yeah, we know this. There's defined speed bumps there, but we're also confident that fusion is safe and fusion is going to be something that people want. So we're going to go out there and we're not going to be shy about talking about why fusion is good. At this point, if you ask people whether they think about fusion, they'd say, I don't think about it at all. But that's going to start to change. And so we have to be in that conversation. We have to be working on that. And we are. It's a key target and a key thing to do. But you just got to be open and transparent. I think that's one of the key lessons from the nuclear industry and the power industry as a whole, is assuming that you have all the answers. Well, that's not true. Your customers and the community have concerns, and you got to really address them.
All right, we got time for one more question. There's a number in the chat that are all sort of focused on some of the technical hurdles and the viability of the different options. But maybe the one that summarizes the best is, maybe you could talk a little bit about the technology readiness levels for some of the different confinement options and some of the different approaches that are being taken, and how you as an association sort of think about assessing and balancing the support that you put forward for the different types of opportunities.
Yeah, so the TRL stuff, it's really important, and it's even within all of the different approaches, there is a range of TRLs in all of the different, what's the TRL level for, the tritium fuel supply loop versus the TRL level for the fusion core itself and all of these other stuff. And so, yeah, I'm not going to get into details on all of that, because it's wide and challenging. There's for the most part, we are confident that we are beyond the kind of basic science understanding. We know enough about the science to move forward. And we have our roadmaps. Each of the company has their own roadmaps. And actually, I mentioned in there, there's this upcoming DOE milestone-based program that's going to be investing government dollars directly into fusion. And one of the key first steps of that is going to be putting together a national team for each different approach, and then identifying what's the roadmap and what are the key milestones and hurdles that have to get there, and that'll all be publicly available. So that should be coming out. Well, we expect the funding opportunity announcement to come before the end of this fiscal year, so the end of September. So all of this is you have to work in conjunction with the scientists, and science is an open process. So it's going to be out there. It's going to be I always tell people fusion's hard, and there's lots of stuff that we need to do to get from here to there. And so we need a lot of help and a lot of science to be able to do that. And there's some pathways that are lower TRL, but potentially have cost advantages down the road. There's some that are higher TRL and could be the first ones there. And I can't I can't choose among my children, which is my favorite.
Fair enough. All right. Well, thank you, Andrew, for spending some time with us and giving us the overview of where fusion is these days. It was great to talk with you.
Thank you. And hit me up through the website, fusionindustry.association.org. Happy to talk more.